Good morning, friends. It's another terrific day in Texas. I'm going to break my fast with an awesome mixture and solution. Let's get into it.
Mad Majesty.
Okay, Mr. R likes to break his fast with some debatably nutritious cereal. So, let's take out our cereal. And this is going to be the first part of our mixture. Just going to put some in. Okay, so let's look at the first component of our mixture. Now, it's already itself a mixture. How can we tell? Well, it's pretty obvious. We see different parts of matter that have different shapes, different colors, and no matter how much we combine it, their physical properties didn't change, other than maybe their shape if I broke these little flakes, right? The marshmallow's still the same color. They're still solids. The flakes are still the same color. They're still solids. Let's see. They're still sweet. They're still kind of gross and still kind of stale. So, there's the first part of our mixture. Now let's add the second. Okay, the second part of our mixture is some milk. I'm gonna pour in my milk. Okay. Now, is this still a mixture? Well, let's see. Let's get one of our super science tools. A spoon. I'm gonna mix it up a little bit. Now, can we still see that there's different parts? Yup. Can I still separate those parts? Yup. If I had tweezers, I'm pretty sure I could pick them out with tweezers. If I had a sieve, I'm pretty sure I could separate the milk, right? The only thing that I see is changing a little bit is the milk, but we still have the mixture. It's easily separated and everything is still keeping its physical properties. Let's see. Yup. It's still solid. It's still sweet. So there's the first part of breaking our fast, our mixture. Now Mr. R is gonna do the next part, a solution to wash this down. Okay, now the second part of breaking Mr. R's fast is gonna be a solution. So, right now, we have the first part of our solution. It's water. It's clear. We know it's a liquid because it takes the shape of its container. It doesn't have its own shape. And, it tastes just like water. Okay, now, let's look at the second part of our solution. Boom! Tang! So, our Tang is a solid. I can feel it. They're like little balls. Let's see, they're white, maybe a little light orange. And, they're pretty sweet and a little tangy. So, now I'm gonna combine them. Whoosh! Okay, now that I've combined them, I can't really tell the difference between particles of Tang and particles of water. It kind of all looks like one thing now. So, that looks like it's a solution. It looks like one thing, and physical properties did change. The physical properties of our Tang changed because if we look, there's no solids in there anymore. They dissolved, right? So we only have liquid. And our liquid also changed color. And let's see. Our liquid also doesn't taste the same, right? So the physical properties of the liquid and the tang both changed, and it looks like I can't really tell the difference between them. They have one uniform look. I wonder if I could still separate this. Okay, so after evaporating the water and some vigorous scraping with my awesome science tool, let's see what we got here. This tang, well, it seems to be solid again. Some parts are a little shiny, but it looks like it's orange. They're a little stuck together, but it looks like they're shiny, solid rocks again. All right, well, there we go. After we evaporated the water, the tang basically went back to the same physical properties it had before. Maybe just a little darker and a little more clumped together. No, I'm not going to taste it. All right, friendo, so let's discuss our observations of my breakfast. First, the cereal is a mixture. First, how do we know that? No matter how Mr. R mixed it with his grubby fingers, it would not turn into one singular uniform looking substance, right? You could still tell the marshmallows apart from the flakes really easily. You could separate them by some mechanical tool with your fingers, with some tweezers, easy. Even when I added the milk, right? This is where some kiddos get confused, even with the milk. Okay, it's still a mixture. Even when I mixed it a bit, right? All of those different materials and substances still retain most of their physical properties, and they were identifiable as their own things inside of the mixture, right? So sometimes when those mixtures start to blur the lines, they're still mixtures. We just refer to them as homogeneous mixtures. Now, our solution was the tang. We know it's a solution because after Mr. R mixed it all up, that had one uniform look, right? Easy peasy. Now, I had to evaporate the water in order to separate it. And after I evaporated it, the only thing that was left was the tang. So, our big takeaways are, if we mix stuff together, as long as we can identify the different stuff we mix together after mixing, and we can still separate them, even if it's not easy, that's a mixture. If we mix them and they turn into one solid uniform look, and we have to evaporate one of the substances or heat one of the substances to get them to separate again, well, that's a solution. All right, my friends, thank you for helping me break my fast. That's breakfast. Now you know. All right, my friends, don't forget, okay? We can't have a brighter future without a brighter you. Bye.